Power Testing and Technology Institute carries out testing, evaluation, and technology development to improve the performance and reliability of products in 8 laboratories. Let's begin with the High Power Laboratory. High Power Laboratory simulates the fault conditions in power system. For this, short-circuit generator, high voltage, and low voltage testing transformers are used for testing power sources to verify the electrical and mechanical performance of circuit breakers. Disconnecting switches, switch gears, fuses, and many other electrical equipment. The tests include a short-circuit test, short-time withstand current test, internal arcing test, and various load switching tests. Now, let's look at a number of important test operations. This is a successful case of MCCB breaking testing. MCCB is installed on a base plate and wired with test wires based on the rated current to build a short-circuit testing circuit. Test engineer calculates and determines the test conditions and instructs the test operator to start the test. LS Susol MCCB has successfully cleared the test current without any damage on its appearance. This is a successful case of an MCCB discrimination test. Discrimination tests are conducted to verify the backup braking performance of MCCBs. In this test, only the subbreaker directly related with the fault circuit should be tripped, while the top breaker is not tripped to secure power supply to other healthy circuits. As you can see, only the subbreaker was tripped to prove its reliability and ability of discriminating operation. This is a successful case of an ACB braking test. ACB is installed on a base plate and connected with bus bars based on the rated current to build the short-circuit testing circuit. LS Susol ACB has successfully cleared the test current without any damage on its appearance. This is an internal arcing test on a load break switch for overhead line. The test current was 20 kiloamperes and the making time was 0.5 seconds. This is an internal arcing test on a switchgear cubicle for ships. The test current was 20 kiloamperes and the making time was 1 second. This is a test on a cable bundle with 20 kiloamperes current to show the electrodynamic forces exerted. Low voltage laboratory is for the electrical performance tests of molded cased circuit breakers and magnetic switches under 1000 volts. Current carrying capacity is verified by temperature rise tests. Dielectric insulation is verified by withstand voltage tests, and load current switching performance tests are also performed here. High Voltage Laboratory verifies the electrical insulation performances of high voltage breakers and switches operating at the voltage higher than 1000 volts through lightning impulse voltage tests. In addition, abnormal voltage that might occur in ordinary operation is simulated with power frequency withstand voltage test, and internal insulation failures are tested with partial discharge tests. Current carrying performances are verified through temperature rise tests. Lifelong durability is evaluated with electrical and mechanical operating tests. Furthermore, water and dust tightness of enclosures are tested to determine protection class. Environmental conditions at installation is one of the stressing factors, for which controlled temperature and humidity, vibration, and corrosive gases or salt mist is provided as the test conditions. Electromagnetic compatibility is verified in this laboratory for the susceptibility and interference performance. Their major concern is how well they endure the electromagnetic noise and how small they interfere other equipments electromagnetically. Electronic equipment like electrometers and digital protection relays are tested in this laboratory to verify its characteristics, accurate operation, and protecting performances. Synthetic tests use separate voltage source and current source. The current is supplied from a short-circuit generator, and the voltage is supplied from a large-capacity condenser bank. And they are synthesized to simulate the field conditions to evaluate the performance of high-voltage circuit breakers. Calibration is made on every testing equipment and measuring instrument for length, mass, electricity, and temperature. PT&T also performs research and development works to shorten the test time consumption, to save the investment, to develop necessary techniques in advance, and to give solutions for the failed tests. For example, high-power tests result analyzing software, artificial fault generator for KEPCO Gochang test station. We have developed a pole transformer short-circuit test system for KEPCO Uiwang test station. In addition, we have developed a lightning impulse test software program, high-power test parameter generating software, temperature rise prediction software, and an apparatus to save the failed test piece for its failure analysis. In addition, we have developed 4-parameter TRV generating method from 2-parameter TRV circuit, a current zero anticipator, and a dielectrically isolated DC power supply. PT&T is accredited as an international testing and calibration laboratory by the Korea Laboratory Accreditation Scheme. KOLAS is operated by the governments, and it's one of the efforts of many mutually recognized countries to remove international trade barriers by accepting other countries' test results. PT&T also maintains close cooperations with KEMA of the Netherlands, UL of the USA, CESI of Italy, and other testing and certification bodies. Many customers have been visiting our laboratory from all parts of the world. PT&T will continue its best efforts to improve the reliability of LS products and secure top-class quality.